Welcome everybody to the Smackdown. We're smacking down flat Earth tonight, and we're actually going to do a little bit of real science at first. Really, this is I gotta be clear with here. This is just is basically a bait and switch, right? So you think you're all here for Caitlin, right? Because she's got some amazing stuff, and then we're gonna look at some derp from one of the dumbest people you'll ever meet in your life. Anyway, here's Caitlin. Hey, everybody. There she is right there. Hi, Caitlin.
Hello. Yeah, no, this is totally a bait and switch. So basically what happened is on, I think, Friday, or not Friday, it was before Friday. It was sometime last week.
Yes.
I sent you some pictures. So I knew that MCToon was going to be debating Mikey and Sam.
It's not framed as a debate, but yes.
Okay. A discussion.
Yeah.
You will be destroyed by them, of course.
He's the real star man, the GOAT.
Yes, the greatest of all. So I wanted to set you up for success. So I was sending a few files, and I found something on Astronomy, which I thought was pretty cool. So I'm going to share if I can figure this out. Let's see, browser sharing. Here we go. This is what I sent you. This was from Astronomy, and this is a spectrum from Sirius. And I was like,
that's Mikey's favorite star.
Yeah, it is his favorite star. And somebody who wasn't NASA, Stephen Finuti, took a picture of the spectrum of Sirius. And I thought, oh, well, Mikey will love that because he's always trying to figure out what the stars are made of.
Yeah.
He's like, oh, it's like, maybe it's electric. Maybe it's this or that. But you know what? It is actually, you can figure out pretty much what it's made out of from this spectra. And in particular, we were looking at the bomber line. So the bomber series, which are these lines that show up over. You can see it right here in the browser. There's like deep red, that's hydrogen alpha, hydrogen beta, so on and so forth. And if those colors show up or don't show up in a spectra, in this case, they don't show up, you can see, yeah, that's hydrogen. Like, that's what it is. And so MCToon's like, you should come on and talk about this. And I was like, yeah, I can. This is basic Common Core. I have no business teaching this to like any higher ed. I barely do spectroscopy, but I can teach middle school and I can teach high school.
That's all you need for this topic is middle school.
Yes. So. Yes. Don't ask me for specifics. Don't ask. The whys can only go so deep before I have to give up. But we can talk about this. And so I have, let's see. Yes. So there's a lot of stuff you can do with light, and you don't necessarily need to image the thing in order to get data from it. So this right here is, and this right here is an infrared camera.
Oh.
And this is really useful in my lab because if I have a component on a circuit board that I think is overheating or is short-circuiting, I can point this at the circuit board and get the temperatures of all the components at once. Each pixel is a temperature.
Uh-huh.
So you don't necessarily need like a full image. You don't need to like have details in order to get useful information from light.
Now, when you point that at the moon, it gets negative, right?
Unfortunately,
it's negative Kelvin.
It is not negative Kelvin. I don't know how well it images the moon. There's a big atmosphere in the way.
Oh, what a pain.
Yes. We can do that one day. I don't think it does it particularly well. The moon typically has temperatures between like 100 Celsius and like negative 100 Celsius, depending if it's a full moon or a new moon. But we'll see. Anyway,
don't tell them that they'll get all confused.
Yeah.
If you, oh my gosh, it's 100 Celsius. Well, what's that in Fahrenheit? They have no idea. It means nothing to them.
Yeah, it is boiling hot.
Literally.
Yes. Of course, things just boil instantly in the vacuum of space.
Of
So,
course.
all right, so let's talk about spectroscopy. Like I said, this is middle school. I did double check. So you learn about basic spectroscopy in middle school, and then you learn a bit more in high school. Okay, so this should be a refresher and not a, this should not blow anyone's head. This is not new science by any stretch of the imagination, except maybe to Mikey and Sam, who I think might want to know about this. So how did this get started? Well, there were two people involved. There was Gustav Kirchhoff and a guy named Robert Bunsen.
Oh, of burner fame.
Of burner fame, yes, that Bunsen. And so basically, Bunsen invented this burner, and he's like, "Oh, this is so cool! I'm gonna burn stuff." Like that's the first thing he did with his burner. And
then he was on the Muppets.
And then he was on the Muppets.
Yeah.
And that was it. So he looked at the color of burning salts, and this is basically the same thing how fireworks work, where you mix, like copper in, and you get like a green flame and everything like that. And he's like, I really want to study the colors, but like it's hard to describe like what kind of green it is. And then Kirchhoff's like, dude, just use a prism. Like, I think I have one here. Yeah, I do actually have a prism. By the way, I did not prepare much for this at all. But yeah, it's just a prism. And for people, this is the Newton prism, you shine light through it, made a rainbow. And Bunsen's like, dude, you're a genius. and so he started looking at it, and they're like, and they built these like equipments with like telescopes on both sides and like a prism. And they're like, whoa, this is awesome. And what was really cool is they got it so fine-tuned that they realized they could see sodium when it was like 20 millionth of like the total thing that was being ionized. So like we can see there's like sodium in there. And they went on and they burned more chemicals, and they were able to discover even more
spectra.
More spectra. I was gonna say more periodic table elements. So I think it was like rubidium and cesium they discovered.
Oh, and they found new elements because of it.
Yeah, exactly. Yeah. They found new elements they didn't know before. And so the way this works is just like we looked at the Balmer lines to figure out that like hydrogen was coming off of Sirius. They did the same thing. They just lined up the spectra and were like, okay, cool. There's new stuff here, and there's sodium over here. And then something really cool happened. So Kirchhoff was like, all right, this is cool. I'm going to make this like mega experiment. I'm going to burn sodium, and sodium has like this bright yellow line. It's really easy. If you've ever seen a sodium street lamp, it has that yellow tinge. Sodium burned really yellow. So Kirchhoff put a lamp behind some burning sodium and was like, I'm going to make mega yellow. The light's going to combine. And then something weird happened. Instead of making like ultra yellow, there was like a dip in yellow. There was like a line, like the color was missing. So what ends up happening is that if you have a bright object, like what we call a black body that's like radiating lots of heat, like an incandescent bulb, behind a element that would give off light when it's ionized, it actually dims that spectra. So you can see what's there based if there is a line or if there isn't a line. That's super cool.
Yeah.
And and then he was like, wait a minute. I've seen this before outside. Like he went outside, like he had a life apparently. And these are called the Fraunhofer lines. So if you go outside, you can view the spectrum of the sun, just like Newton did. But if you do it really closely, you get on a microscope, you'll see that there's these dips in the lines, and they're like, oh, whoa, this is cool. Now we know what we're looking at. We're looking at elements absorbing light. And so that's the first time we're like, hey, we can use this to explore space. And the first thing they discovered was another new element called helium. Get it? Helios, like the sun?
Yep.
So they're like, this is awesome. So this started stellar spectroscopy. And eventually, like Kirchhoff went off and wrote about like black body stuff. and was like, okay, like if anything is like perfectly black and it like heats up, it'll produce lights, but they didn't know the equation. And then like 40 years later, like I think Max Planck came along and was like, hey, I can solve this, and came up with, you know, H equals HV. And then Einstein took that and was like, this is a quanta of light. So there's this like straight path between like cool rainbows to quantum physics.
Yeah.
So yeah, so how do spectrographs work? Spectrometers. Okay, so I have a few here. So this is the one you'll see in your science class. I stole this from a classroom. You look through one end. You won't be able to see this, but you look through one end through this hole, and there's like a slit here, and then you see a little rainbow on the other side, and you kind of sort of see spectra. And if you're really good, you can make some stuff out, but I cannot. And then there's this stuff, which is, I don't know if I can reach because it's plugged in, but this is a like cheap Chinese spectrograph or spectroscope, spectrometer. And you just point it at a light source, point the white thing at a light source, and it will tell you basically what it's comprised of, the spectra. And the way this works is that there is basically a diffraction grating in the front here and a little camera. And this is how they all work, by the way. There's a diffraction grating and a camera, and it just splits the light up into a rainbow. The camera receives the rainbow and then determines, based on what pixels are lit up, what color it is, essentially. And if you're wondering what a diffraction grating is,
it's a screen door.
Yes. Well, no, it's a
vertical
rainbow. Yeah. Well, no, it's a rainbow generator, essentially. If you remember the like double slit experiment, where if you had like two slits, light goes through and it creates an interference pattern. If you multiply that a lot, so this one I think is, let's see, this is like 1,000 lines per millimeter. You can diffract it a lot and essentially make rainbows using the same process. The more slits you have in the double slit experiment, the tighter the measurements are. So if you want to like measure the wavelength of a red laser, instead of using double slits, you could use like 10 slits and get very precise measurements about where the laser is interfering. But 2 is kind of mushy and, you know.
Yeah.
Anyway, so it's very basic. These things are not very advanced. You would think because all we're doing is measuring color, we should be able to just do it really easily and cheaply, but we can't because we do not have color cameras, which sounds really weird, but it's absolutely true. There was this movie recently called Project Hail Mary, and they were talking about how this alien culture had different technology from humans. So, for example, they didn't have eyes, so they didn't have screens, but they had really good mechanical skills because they had echolocation, and their screens had to be like 3D and pop up out of the material. Our cameras are like the same way. They were built specifically for humans. If our eyes were better, we would have cameras that could actually record color, but instead we have red, green, and blue cones. So basically what we do is we take 3 monochrome shots, one in red, one in green, one in blue.
You just put a filter in front of each of the pixels.
Yes, exactly. And combine them together. And so if you were to make a spectrograph out of that, you would say, oh, there's a little bit of red here, blue. It would be like 3 points. And you'd be missing a whole lot of color information. So, and no one has devised a way to make this cheaply. I think there were some early efforts when photography just started to make actual film that would show like real colors, but it never developed anywhere. The film that we did develop, like the Kodak type film, that uses the same process, only with like silver crystals, essentially silver salts.
Yeah.
It would be like...
They only react to certain colors of light.
Exactly.
Yeah.
So we don't have color cameras, and that's why these are so expensive. So the one I showed is like $150, which sounds expensive, but is super cheap. If you go on eBay and try to find like a professional, spectrometer, that's like $70,000, $80,000 easy. It gets expensive real fast.
Yeah. But
so anyway,
but the technology is not a whole lot different.
Well, it
right?
depends what kind. Yeah, well, it depends. Yeah, the technology is not that much different. A lot of the more expensive ones will have like a little slit that like rotates around, so it looks at a very small spectra, but very in depth, and then does that over and over again.
Mm.
So, and then there's other types of spectrometers, which I don't want to like confuse people too much about. Like there's mass spectrometers, but that has nothing to do with light.
It's nothing to do with, yeah.
Yeah.
A friend of mine worked at a lab where he worked on a mass spec machine, and it's a giant coil of glass tube.
Yes.
And you heat up stuff that goes into one end, and it just goes around and around and around. And then they pop out at different times. And the timing at which something pops out is how you know it's mass.
Exactly.
So, and then they need to calibrate it. So they'll take something that they know. They'll say, well, here's something, whatever it is. He worked on volatiles. So it's like, here's some acetone. So they'll put in some acetone and it'll pop out at a certain timing. And they'll use that to calibrate the machine. So.
Yeah. Basically, the only people with those types of spectrometers are people who are developing drugs and vaccines, or work in very specific food industries.
Or testing water.
Or testing water, yes. So if you're doing like deep chemistry, you might have those. You don't see those in many other labs.
No.
Like I've been in
Very specialized.
I've never seen a good spectrometer. Lots of good electron microscopes, but anyway, so let's continue. So let's do some experiments. So we do have a spectrometer here, so we'll use it to do some fun stuff. Let me figure out how to do this. Windows. Okay. So this is the software. We're using Flame Eye. And I'll make this bigger so you can see it. Maybe. There we go. All right, where is it? Where did I put it? Here it is. Okay. So if I aim my spectroscope at the screen, you'll see that there's oops, come on, be faster. Yep, there's sort of a hump in red, a hump in green, and a hump in blue, because all screens are red, green, and blue pixels. And for some reason, there's a slightly more blue in this screen. I'm sure there's a reason for that, but I'm not going to find out today. The other thing here I have is an LED lamp, and I don't know if you can see this, but it can change the color temperature. So I'm going to turn it on. All right. And I'm going to change it to be like pretty white. I'm going to shine the spectrograph at it, and you'll see what's going to happen. We see, oh yeah, a lot of blue and not much red. So what happens when we change the color temperature? We see that the red goes up. So basically, we've reverse engineered how this light works. When you change the color temperature to be 3200 Kelvin, it turns on red lights and diminishes the blue lights. And when we change the color temperature to 5600 K, it makes the red go down. And by the way, this graph where you have this sort of blue bump and then sort of a dip and then the rest of the spectrum is very common with modern LEDs. Basically, the way they work is that they have a blue LED in the back and then a phosphor coating. And that's what you're seeing here. You see the blue LED in the back, and it activates the phosphor coating. So yeah.
And the phosphor changes the frequency a bit of the blue to be a broader spectrum.
Yeah. So the blue LED only puts out one frequency of light, which is great if you want to see blue. But if you want to have like white light, you need the blue and the sulfur coating. The sulfur converts the blue into a broad spectrum, essentially. Yeah. So I also have something really cool here. So I was like, you know what? We should actually do spectroscopy. And we're going to do it cheaply. Let me see if I can't find my thing here. Here we go. All right. So over here, let's go down. You see it? Oh, let's get this out of the way. Okay. So down here is a little Tesla coil. And I like you guys so much. I went onto eBay and I bought a whole bunch of glass tubes filled with gas. We all love gas. I know.
I love gas.
Yes.
I had gas earlier today.
Oh,
That's because I had Indian food yesterday.
not that kind of gas.
It also opened my third eye, if you know what I mean.
So I have a mystery tube. Let's see if we can. Where can we put this so it doesn't get in the way? There we go. I have a mystery tube. And we're going to put it on the Tesla coil.
I see what we're doing.
And
is it glowing?
Not yet.
Oh, okay.
So I have to do something. I need to go. So like I said, I am super cheap. We need to make this, we need to oscillate the Tesla coil fast enough so that it lights up continuously. There's no built-in function to do that, but there is a Bluetooth player. So I am going to connect.
Oh, you're just going to play a tone on Bluetooth?
Yes. Yes. 4K tone on Bluetooth.
Nice. I knew somebody that was, that had perfect pitch, and I just play notes all the time. Be like, what's this? She's like, it's A sharp. How do you do that?
All right, there we go. I have it connected. Tone gen. See if this works. Yeah, it works. Okay. Yes. I told you I'm super cheap, but it works. Okay, so
that's 4,000 hertz.
That's 4,000 hertz. Yes. 4 kilohertz for those that like to do things correctly. Okay.
Correctly.
So we're going to try to figure out what's in that tube before my house fills up with ozone. So yeah, here we go. It's pointed at my screen so it sees stuff right now. I'm going to hover over the stop. Okay. Okay. All right, this is hard. All right. Wish me luck.
Luck. All right, we got it.
We got it. Awesome.
1, 2, 3, 4 big lines and then some smaller ones. All right, so now we need to look up some lines. So is it a single element in there?
Single element.
Okay.
We see a lot of red, and we see a big spike in yellow. Oh, I didn't stop it. Oh well, you saw it. I'm not doing it again. So we saw a few. Let me actually move my camera back. Come on. Oh, here we go. Oops, wrong way.
Is that camera on a gimbal that's motorized?
Yeah, of course.
Okay.
Why wouldn't it?
Why wouldn't it be? Of course. I love it.
All right, so let's try to find what gas that was. So this is helium. We did see a yellow spike, but we also saw a bunch more red.
Yeah, that's missing.
I mean, maybe, but I mean, we also are not seeing a lot of blue. This is neon. This is argon. We definitely don't have the yellow
busy.
spike here.
That's super busy.
Yep. Here's krypton. Now, we do see a yellow here, but we didn't see like a green.
Yeah.
And the red's not as pronounced as what we saw. And we have xenon, which is sort of all over the place.
It's busy too.
But it's actually mostly blue. If you were to look at it, it's mostly light blue. So let's see. Let's see in the chat. We have...
Somebody guessed that it was ozone.
It is not. Well, yes, there's ozone filling my my apartment every time I turn on the Tesla coil. But it is either, we know it's going to be helium, neon.
Oh, it's a noble gas in there?
Krypton. Yeah, it's a noble gas. Krypton or xenon. What did I miss? This is cool. Yeah, we're using Tesla coils.
You don't know what it is.
Yes. You don't know what it is. So
no, do you know what it is though?
I know what it is.
Okay,
I know what it is. I want to chat. Put in your best guess.
All right, we got a couple. We got Decal Badger saying neon. The Canadian Space Advocate says neon. Real Cygnus. Patch Von Braun. Big Fish. Red Cedar. Max says mustard gas.
Mustard gas.
That's what Max gets when he eats too much mustard.
Yes. Radon. Oh, I like that. I wish I could get radon. For some reason, they don't sell radon tubes.
It's for some reason.
Yeah, for some reason.
What about uranium hexafluoride? Is what DK Shadow wants.
Nope. And so a lot of people figured it right out. It was neon. We had the bright red, that really sharp yellow, and then not much above it.
Okay.
So that is what you're doing with spectroscopy. You can use it to identify elements, even on cheap Chinese cheapo spectrometers. Like,
nice.
Yes. All right. Oh, the other thing I did, I took that little cheap spectrometer outside, and I took a view of the sky. So now we're going to start doing like real spectroscopy.
The blue sky or the
blue sky.
Okay.
The blue sky lit by the sun. It was this evening.
Now, in case some people are in the UK, the sky is blue at times.
Yes, the sky is oftentimes very blue here.
Yeah, especially in California. Yep.
It never rains or hails, really. It's perfect weather.
Had some hail around here today.
Yes. And you can see some of the Fraunhofer lines that were mentioned, that I mentioned earlier, with Kirchhoff, who was like, hey, if you go outside, you see these little dips.
Yeah.
And you can see that here. Now, I was not pointing at the sun. I was just looking at the sky. And so if you look here, we see around 750 nanometers. We have this telluric O2. And if we look back here around 750, this is caused by oxygen in the atmosphere, this dip.
Ah.
Yeah.
What frequency is that?
Frequency, you would have to convert 759.37 nanometers to terahertz.
All right. But there it is right there on that one.
Yes.
Yeah. Okay.
Yes. And then let's see, we saw some dips up here, and that is caused by hydrogen beta from the sun, I think. But yeah, you can just take it outside and start analyzing the environment. See what's out there. See what is. And by the way, when we're going to talk more about astronomy and spectroscopy, every time you look at a star, you are looking at it through the atmosphere. So you will see these dips like in your data. And so you have to take that into account. Like, oh, there's oxygen here. Of course, that's why it dips. So
So if you're doing spectroscopy through the atmosphere, those are knowns. We know what's in the atmosphere, so that's always going to be absorbed.
Yep, and that's one of the reasons why we put spacecraft like James Webb in outer space, so we don't have that pesky atmosphere, making our spectroscopy of planets, exoplanets, more difficult. So if you cannot resolve anything in space into like an image, all we can do is spectroscopy. And so, for example, if you want to like figure out what an exoplanet is what the atmosphere is made out of, you wait for it to pass in front of its star, and then you do spectroscopy on the light coming in, and you can figure out exactly what's in that atmosphere to a certain extent. That is, if you have billions of dollars, you can put one up. We can't do that.
Just a few people can.
Yeah, a few people can. And in astronomy, so we figured out we can look at the sky. We can figure out, we looked at Sirius at the beginning. We're like, okay, there's hydrogen here. Generally speaking, when you look at stars, you'll see hydrogen, helium, and like calcium. And if you're like have really good equipment, like a few other trace elements. But it depends on the size of the star, like kind of what you see. Like really bright stars like Sirius, you'll probably only see hydrogen. But some of the less bright stars, like the M-class stars, they will, like the red dwarfs, they will actually let you see more elements, which is kind of weird.
The Sirius is hard because it's so bright.
Yeah, the spectrum that comes back from really bright stars don't show the elements very well. Except like I said, hydrogen. Why this is, I told you, don't ask me too many whys.
Ah. Need one layer deeper on the why.
Yes.
Okay.
I only work in space. I'm not a professional astronomer. So, it's like, okay, so, but there's some other things we can do in this.
But before you do that, we have a question. A lot of people are asking. Just a second here. Hold on.
Man, this is gripping time.
I know. I'm sorry. I queued it up so well and then failed. Hold on. I got it. You know what? I need to fix this app. I think there's an issue. All right, here we go. Ready?
So my question is, spectroscopy needs to be in a container. Otherwise, you don't know what
Spectroscopy needs to be in a container. The study of how light interacts with matter needs to be in a container. What does that mean?
Otherwise, when you're looking at the moon, you don't know what gases you're seeing in between us and the moon.
Gases? The moon is solid. The moon is a solid object.
How do you know?
Yeah, you're literally just looking at the light there, and like I just showed you. I pointed it up at the sky. There's no. Yep. Anyway, there is no. You do not need a container for spectroscopy. Although I will say that if you do want to look at neon, at home, you better keep it in a container, or else it gets everywhere.
You gotta wash everything to get the neon out.
So that was in a container, but you don't need a container. And in fact, one of the most popular uses for spectroscopy outside of like science is paint mixing. Like if you want to know the exact color of paints, you can take it to the store or buy like $1,000 piece of equipment and figure out the exact ratios of paints.
Now, what store might you bring it to?
Oh, Axeman's.
No, you'd bring it to Menards.
Oh, Axeman.
You gotta bring it to Axeman. Oh my gosh, Axeman doesn't do custom color paints.
I'm gonna make a pilgrimage every year to Minneapolis just to go to Axeman.
She's saying that because when she was in Minneapolis it was June, right? Yeah. We went to Axeman. If you guys have never been to Axeman, you are missing out. It is a nerd paradise.
It is. There are so many vacuum tubes.
Yep. Oh, boxes, bins of jumbled vacuum tubes.
Yes.
You're like, oh, I want a vacuum tube. Which one do you want? Oh, I forgot. Well, you're out of luck.
All of them. Want all of them.
Oh, yeah. Oh, Icy Spin says, what's that round trip time? So it's the mean time to Menards and back, the MTT MAB.
Yeah, there's no Menards in California.
Yeah, so your
Menards list.
Your MTT MAB is pretty stinking high.
Yep.
For me, it depends on traffic. Can be 40 minutes if I'm lucky, but that's not usually lucky. But of course, I mean, you can't go to Menards and not be there for at least an hour because, it's Menards. It's the best toilet store around.
Yeah. If you want a toilet, go to Menards. Okay, so what else can we do with spectroscopy in space? Well, we can figure out what stuff we're made out of, which is really important for someone like Mikey, who's a little confused. But we can also use Wien's displacement law, which is also super amazing. So the temperature of a black body can be, if you look at like the peak of your spectrograph, like what color comes in like the hottest, you take that wavelength in nanometers, and you multiply it. Sorry, it's the temperature in Kelvin times the wavelength in meters is equal to Wien's displacement constant, which is 0.00289, I think. So if you want to find the temperature, of a star, you just find the peak wavelength in meters,
Okay.
and you put 0.00289 above it. So it's 0.00289 divided by the wavelength.
Which is
Now you know
a very small number
Very small number.
because
We're
it's
talking
in
about
because the wavelength isn't in meters, it's in nanometers. So you got lots of zeros after the decimal.
Yes.
Right,
Yes.
so
if the wavelength is in meters. That's why the number is so small.
Yes.
So in meters, it's 0.0000.
Yeah, that's yeah.
Yeah. So you do that, you can get the temperature of a star, and it follows the basic HR diagram, the Hertzsprung-Russell diagram, which actually I think I have here. I do. Okay, cool. If I can figure out how to use my computer, cool. So this is the famous Hertzsprung-Russell diagram.
Oh yeah.
If you take
can you
astronomy-
zoom in a little?
I don't know. This is hard. Oh, there we go. Zoomed.
Perfect.
So we have the main sequence stars are this band in the center here. So these are stars that were born and they're in their main sequence of their lives. And then sort of above that, you have these like giants and supergiants. So these are stars at the end of their lives. And you see when they're red, they're cooler and smaller. And when they're blue, they're hotter and bigger. And then they get to these supergiants and they sort of change color again. And then when they go nova or they shed or something, they become white dwarfs and they become very hot again, but very small.
Okay. What's that one on the very topmost on the right?
Topmost on the right, that is Betelgeuse.
Sorry, what?
Betelgeuse.
Well, I'm sorry, one more time.
Betelgeuse.
There you go. Okay, thank you.
So anyway, now that I've invited a poltergeist into my house, thank you very
You guys, it's always nerd time here. Just so you know.
So Betelgeuse is it's giant. It's not too far away, stellar wise.
And everybody keeps saying it's gonna go nova here.
Yeah, we don't know when it's gonna go nova.
Yeah.
It might be tomorrow. It might be in 10,000 years. It might be 40,000 years. Who knows? I'm not putting any money on it in my lifetime. Now, interestingly enough, if you have really good optics, you are a university, and you have a giant telescope, you can image Betelgeuse's surface to an extent. You can see like little pixels. You can see it's like cloudy, like it has like hot spots and like cold spots. So
wait, you can resolve more than one pixel?
Yes, of Betelgeuse. That's the only star.
Oh.
Capable of being. I was surprised to learn that too.
With an earthbound telescope.
Yes, not an amateur one.
Yeah.
I don't know how to. It's like Betelgeuse or something. Betelgeuse telescope. Yeah, there we go. Like stuff like that, where you can sort of you can see that it's not amazing, but you actually can make out some details if you have really good optics, and it's basically like it's a blob right now, sort of changing shape and having these like bright spots and like dark spots. It's pretty cool. It's the only star we can make out, and by we I mean not me. I don't.
Humans.
Yes, humans. All right. So you can use the temperature to figure out what kind of star it is based on the HR diagram, using spectroscopy, just looking at the peak color. And then there's some other things you can do. So you can look at the spectrograph, and if the lines are shifted to so they're redder or bluer, you can tell there's blue shifted or red shifted. So now you can use spectroscopy to also figure out if the stars are moving towards you or away from you. So that's another thing.
Or if we are moving toward the star part of the year and moving away from the star part of the year.
Yes, you have to be very precise in your measurements to do that. I would highly recommend going into radio if you want to do that.
What's really cool, right? Where you're looking at something you had that was $150 Chinese thing, right? And I don't know if that's probably not precise enough, but they were able to do that in the late 1800s. Vogel and Schneider did that.
Yeah.
Were able to measure the shift, the 6-month shifted offset shift in the red and blue because of the orbit of the Earth around the sun.
Yep.
Super cool.
Exactly. Yeah, you don't need you like I said, the spectroscopy equipment is very expensive, but if you have good ones, you can figure that out. But if you don't have good ones, and you want to see Earth's shift around the sun, I highly recommend getting yourself, and I did not even intend, I swear to God, I just had this out. Get yourself a software-defined radio and a radio telescope, because this can resolve very precisely, like the hydrogen line and stuff. So, and the hydrogen line will also shift, and it's basically spectroscopy as well, but it's just radio.
Photons are photons.
Photons are photons. And the other thing, there's one more thing you can do with spectroscopy. If you look at the lines and they're slightly wider than they should be, do you know what that means?
It's been eating too much.
Sometimes. Oftentimes it's actually, if it's wider, it's actually been shedding weight. Believe it or not. So when a star is spinning, one side is moving away.
Oh.
And the other side is moving towards you.
Yeah, okay.
So you get both blue shift and red shift. So the lines, the spectral lines become...
the lines get wider.
Yes.
Not the difference between the lines.
Correct.
Okay.
The lines
Okay, that's what I was
get
thinking.
lighter.
Okay.
Yeah, so you can measure the rotation rate of stars using spectroscopy if you had really good equipment.
Yeah.
Which you can sort of do at home, and I will tell you how to do that. So if you want to do spectroscopy at home, you have to get yourself basically a filter that has that will like create a rainbow on your sensor. And as far as I know, there's one thing that like everyone gets, and let me pull it up. Let's see, browser sharing. Here we go. This is the Star Analyzer by RSpect. It's about $200, so less than a pair of binoculars. You too can start doing spectral analysis on stars. And all this is it's a camera lens, a camera filter.
The filter goes in front of the camera lens.
Yes, and it's a diffraction grating. And you put that in front of your camera, and it'll create rainbows next to the stars. And you can see what the stars are made out of, and that's what we saw on Astrobin. Someone did that. They probably used one of these. And what's interesting is that you would think we're looking at rainbows. We should probably use a color camera, but it's actually recommended that you use a black and white camera. And then you just measure the distance because red is over here.
Yeah.
Blue's over here, and then you just use a black and white camera.
As long as you know which side is red and which is blue.
Exactly.
But it would show up pretty quickly because none of the bands would match if you got it flipped.
Exactly. And then you run the image that you get from your sensor through some software. And there's a few pieces of software. There's this one, which is RSpec, which is their software that you can buy from them. And then there's this one, which is Bass Spectro. And there's this other one called ISIS, which is the Integrated Spectroscopographic Innovative Software. And so you use one of these software tools to analyze your images and then figure out what the spectrum is. And it's that simple. Oh, yes. And then what you'll find is, most stars, hydrogen, helium, calcium. But if you look at nebula, what you will find is that you'll see a lot of hydrogen alpha. So it's like a sort of solid red. You'll see a lot of this like blue, which turns out to be oxygen 3, which is doubly ionized oxygen, and a whole bunch of sulfur 2, which is ionized sulfur. Why sulfur? I don't know. But you'll see a lot of hydrogen, oxygen, and sulfur. And so if you're like me and you live in, oh, yes, I was sharing my browser. Good. So if you're like me and you live in California, in Silicon Valley, and the lights are just absolutely filled with light pollution, and you want to capture dim emission nebula, I use an offshoot of spectroscopy, which is that I have a filter in my telescopes back there and a black and white camera. And so what I do is I record just the hydrogen alpha signal. So it blocks everything but hydrogen alpha. I block everything, and then I take another picture that blocks everything but oxygen 3, and then another image that blocks everything but sulfur 2, which is like a really deep red. And then I take that data and I combine it together to get images of emission nebula that would otherwise be impossible. And so I have an example here of something I took. So this is the Jellyfish Nebula. This is usually seen in the winter, and we can zoom in here and take a look around a bit. You'll notice the stars are like all white because you don't get that nice star color because this is all done in false color. But you can see these.
Why is it in false color? This is the
because I took the image
method that you just described. Okay,
exactly. So I took the hydrogen alpha signal only. So it's a little slit of red light that hydrogen alpha emits on. And then I took a little slit of light that oxygen 3 emits on. And then I took a little slip of light that sulfur 2 emits on. And when you do that, you can essentially see the nebula in really good detail. And that's what Hubble does a lot. So when you see like the Hubble pictures where you have those like interesting colors that almost look like a rainbow, the reason why they have those colors is because it's not a true color image. But what it does allow you to do is it allows you to pinpoint into those gases. So you're sort of doing spectroscopy in reverse. And like I said, this is taken in, borderline zones, but because the only light really coming in are these like narrow slits, most of the light pollution just gets filtered out. And you get these really nice, clear photos of emission nebula.
That's a cool technique.
Yeah. So anyway, totally possible to do at home. Highly recommend it. And the other thing too, I have this wonderful book here, the Spectroscopic Atlas of Bright Stars, and I have here
because people have done this before. Of course, this isn't the forefront of science.
Absolutely not. I warned everyone, this is middle school, this is high school.
Yeah.
But here we have Sirius, and we see the same thing we saw with that.
Those dips.
The hydrogen dips that we saw basically in like this side here. We saw that in the beginning. And then another one of Mikey's stars is Capella, which is a little bit more interesting because I think you can see calcium a little bit more in Capella. Yeah.
Where's calcium? There, it's the second from the left. Yeah. Okay.
Yeah.
All
but
right.
yeah, you can absolutely look at stars and figure out what they're made of, what temperature they are, all this kind of. There's no mystery.
So,
no mystery whatsoever.
I see Spin says, surely you can't be serious.
I am serious, and don't call me Shirley.
Well done. Well done.
Yes. And that is spectroscopy. Like I said, I'm not a scientist. When I do, in the rare times I've done professional astronomy with actual astronomers, all they're doing is spectroscopy. Usually they have these filters on their telescopes and they're gathering data about like the brightness of stars and stuff like that. I just like taking pretty pictures. But if you're really into like just gathering data, that's pretty much what you do. You do a ton of spectroscopy in space.
All right. Well, cool. All right. We've got some. So if people want to ask a question, you can tag Kate or Caitlin, and it will show up on my thing here. It will capture it. I edited my settings to capture that. But you ready for some back and forth?
Yeah, sure. Let's do it.
All right. Let's see. We got Tim Davis. This is whatever started at the beginning. Tim Davis says, not Tuesday, late with Kate. No, late night Kate. Nah, Kate night.
K9.
There you go.
To it. Yeah.
Icy Spin says, wait, I thought Astrocate was, I thought it was Astrocate, not Monkey Cat Pat Pat.
Oh, so yeah. So people might not know this. Mikey has Mikey has trouble telling people apart, and me and Monkey Cat Pat Pat could not be more different. Like absolutely not. But for whatever reason, he thought that I was Monkey Cat Pat Pat for a while, and like really hated Monkey Cat Pat Pat.
He's very threatened by you. It's hilarious.
Yes.
Okay. Tim Davidson says, didn't Superman lock his criminals in Prism? See, it's funny because Crystal Thing would actually be okay, I'll go.
Yeah. So now that you mentioned that, I have to do the Phantom Zone reference. There you go.
Was slowly rotating. I remember just
Yes.
as watching that in space as they were just trapped in there. Tim Davidson, he said he's going to go, but then he comes back and says, dark is proven faster than light. Basically, photons spin and can create voids, and that will move up the line of photons going faster than the light. Super scientifical there, Tim.
This is true. If you shine a flashlight at the moon, you can move it across the surface of the moon faster than the speed of light. But this is an illusion. The light itself is not traveling, or the darkness is not traveling faster than light.
Yep. Was that Veritasium video, I think?
I don't. It's been around for a while.
Yeah.
The whole like, well, I mean, I remember talking about this in high school. Like, if you shine like a laser on the moon, you know, are you moving faster than light? And the answer is, of course not. Yeah.
But nobody's actually shining a light on the moon, Mikey Smith. You didn't actually illuminate the moon with a laser. Oh my gosh.
Oh, but if you could, that'd be awesome.
I know.
Basically blow it up.
What?
If you could shine a laser bright enough to illuminate the moon, that would have so much energy, you would essentially blow up the moon.
The moon?
Yes.
All right. I'm not buying it. I think I know, but I remember that one, but that would be enough to destroy the atmosphere of the Earth. Right? It was about how many laser pointers could you do so that you could see the moon illuminated by laser pointers, right?
Yeah.
I think,
yes.
was it XK? No, it wasn't XKCD. It was What If. It was What If.
Oh, yeah.
Yes.
I actually pulled it up here.
The book he wrote. I have. It's right over in there. I gave it to a kid for graduation one year.
Wrong browser window. Shoot. But yes. No, it would be a lot of power to light up the moon.
Okay. All right. Rossi says, but CC can see the blue sky through the moon.
Oh,
God,
I've been debunked.
They're so dumb when they say that. Every day, some new flurf is reposting the same nonsense on Facebook, and that one's is all the time. Rossi then comes back and says, "Come, Mr. Tallyman, tally me bananas." That's on you. You said that 3 times, not me.
I have a wild beast here that will scare away any poltergeist. People know my wild beast.
Astrocat.
Astrocat.
Unfornicated says, why does all of science discriminate against the colorblind? Wait, you showed me that cat before the video started and it's not moved.
That's how lazy Astrocat.
Are you sure it's alive?
Oh, let me.
Oh, there you go. Yeah, food. Yep. All right. Yeah, why does all of science discriminate against colorblind? You and me both, unfornicated. Unfornicated.
Unfornicated. Yeah, I was gonna say. So the funny thing is, we make a good team because I'm legally blind, so I can't see very well in detail, but I'm not colorblind. And then, so if you want to know what color something is, I can tell you. But if I don't know what something is in the distance, you can tell me. And
I got it.
Works. Yes.
Makes sense. Icy Spin says colorblindness is a psyop debunked this years ago.
Mm-hmm.
Of course. Icy Spin again says, it says, surely that can't be serious. You got the street cred for that, for the correct answer. Tim Davidson says, that's definitely serious, and don't call me Shirley. See, that's Tim got the street cred as well. Jack Better says, does Mikey know this? It could be relevant.
It is very relevant to Mikey. I don't think he would understand.
Well, there's a couple problems. Number one, he wouldn't understand. But even if he did understand, he is resistant to learning.
True.
He has already decided that what he knows is right, and nothing could change it. So that's it. Unfornicated says, what element is the green in Mikey's pick of Sirius?
What element is green? That is non-element. That is so
that's
the element
backward,
is likely,
right?
Yeah, I was gonna say it's chromatic aberration, so it is glass. So silicon.
But we're still seeing green coming from Sirius.
Yeah, and that is because Sirius is quite seriously a black body radiator. So it has a full spectrum of colors like the sun.
Don't tell Quantum Eraser. It'll confuse him so much.
Well, so, okay. I was telling MCToon, I don't know the flirts that well.
There he is.
Yeah, I don't know the flirts that well. Tell me about Quantum Eraser and this stuff about black bodies.
So Quantum Eraser, in his book that I have right here.
Oh, right. That's the guy who wrote the book.
Yes.
I remember that. Yes.
So in his book, he directly tries to challenge the radar bouncing off the sun by claiming the sun is a perfect black body radiator. And has multiple quotes in here from scientists describing what a perfect black body radiator is. So
that goes back to Max Planck, where he was theorizing that if one could exist.
Yes. So somebody commented on hold on. It was I got a bunch of people sent me messages during this. It was Electron Element on YouTube commented on one of his streams or videos, said, in your book, you state the sun is a perfect black body. What experiments or observations back that statement up? And rather than provide evidence, he redefined his incorrect definition of science or experiment. He says also, I never made the claim that the sun is a perfect black body in my book, but all of the quotes that he has, and then he re-quoted them in the response, were quotes by people stating what a perfect black body radiator is. So yeah, he did in his book declare that the sun is a perfect black body radiator by quoting these people, and did not have any empirical evidence to back it up. And when asked for empirical evidence to back it up, did not have any empirical evidence to back it up. So he still shall be ignored or dismissed without evidence, as he has made a claim without evidence.
Well, we can make a claim with evidence. If the sun were a perfect black body, we never would have discovered helium.
Because it's absorbing.
Yes.
Yep. Now, are they going to say it's different because it's being emitted from the sun, not being absorbed?
Well, no, it is being emitted. And it's complicated.
Yeah. Never mind. Answering that question would cause a singularity. So anyway, what is the element? It's not really an element. It's the real question would be if you could identify a lack of a certain band of light in Mikey's picture, but I think it's a little too smeary to identify that. Right?
Yeah. I mean,
that would be the trick. That'd be the thing where you could say that one. Here, we're missing this band, that's hydrogen. We're missing this band, that's helium. We're missing this band, it's whatever else is in Sirius. That was calcium was the other one.
Calcium. Well, yeah, for Sirius, the only thing an amateur would be able to see is the hydrogen. It's too hot. Like I said, the hotter the star,
that's
the more
right.
difficult
Yes.
it is so you would see hydrogen. But ideally you would want sort of a semi-professional setup with like an actual diffraction grating.
No, nothing's better than Mikey's.
I know.
He's the real Starman, the GOAT.
Yeah, he's the first one to discover that you could put up a cell phone camera and digiscope to binoculars, despite the fact that the binoculars that he bought, the manufacturer sells iPhone adapters.
Yeah. Now, I did not know before watching the video that Sam made that digiscoping was a word.
I didn't either.
But it is a word, and it wasn't invented by Mikey, though he thinks he invented the technique, basically.
Yes. Yeah. Whenever I would teach students, I used to teach students astronomy, and I would bring them up, and there's always a student that would put their cell phone up to the telescope, to take the nice picture of the moon, and that was great. And it's what people do. Yeah.
Now hold on a second. You were a kindergarten teacher.
Yes.
You were teaching astronomy in kindergarten. That's amazing. No, that is some gifted students.
I was not. I was volunteering with the local community college to teach astronomy to the public.
Okay. All right. All right. So let's see. We got Frigid PT Force is funding the search for intelligent life in Betelgeuse, starting with this chat. Thank you for that, member. Super chat. Rossi for $5 says, speed of light is 186,000 meters per second, but nobody knows what the speed of darkness is because when you turn the light off, it's already there.
Wherever you go, there you are.
Yeah. You could probably get a Batman thing in there, too. He's the Dark Knight, you see. Icy Spin says, Monkey Cat Pat Pat denies being Astro Cat Pat Pat. Oh my gosh. Rossi says, true fact. True fact. Nobody's ever seen Astro Kate and Monkey Cat Pat Pat at the same place and time.
This is true. Supposedly, you can find streams. But we're not. Hey, did you?
It was all CGI.
Yeah. Supposedly you can find streams with both of us, but we're never talking at the same time.
There you go. All right. Let me see if there's any that are. Let's see. Mr. E-Man says you need to set the laser to stun first when you're shooting the moon. Tim Davidson says, I DM'd you the dark faster than light vid. I don't think I'm going to play it. But, and Eric Burns says, check DM Discord.
You do not want to be put down.
Okay. That's pretty good. Hold on. Let me get this here. All right. Where'd it go? There it is. All right. So people know, we are still negotiating. Sam is trying to change the time of the Mikey and Creaky and Sam stream because it's too late for Mikey. I guess it's past his bedtime. But I'm like, Creaky's like, no, that's perfect for me. That time is great for me. Let's keep it at that time. And Sam's like, we should change it because it's not good for Mikey. I'm like, Mikey doesn't need to be there. What is Mikey doing? He's unemployable, right? What's he going to do on Friday morning? He's going to do nothing. He can sleep in. It's okay. But that's okay. If he can't be there, he can't be there. He'll be there. He won't. He's the GOAT. He's got to be there.
His only job is to stay up late anyway and take pictures of stars through his binoculars.
That's true.
Like, one of the things that sucks, I have a job. I get up at 5 a.m. in the morning.
That how inconvenient of your employer to expect that kind of crap from you.
I know.
Just so that you can pay taxes, so that Mikey can get his life paid for by you. Except that you're not in Canada, so
yeah.
Okay, so we got one from Eric Burns that says, let me see if I can find it here. Where did it go? Where'd it go? Anyway, Eric Burns said the astronomer's periodic table is hydrogen, helium, and metal. But I think it's a different kind of metal. This kind of metal here. Everything is metals.
This is true. I mean, and that's so like the universe is like 98% hydrogen or something. I mean, it's almost all hydrogen, and then stars only fuse up to iron, and then it's like there's a few trace elements that are made during like supernova and stuff, but like, yep, it's hydrogen, helium, metals.
That's about it. All right, let's see. Icy Spin says, oh no, wait, hold on. Icy Spin said, I may not have captured everything. Says something dim emissions nebula. That's Witsit level word salad, bruh. There you go. That's
so actually what happens when I take those pictures, it's basically a image of a ferrocell magnet. and just like the torus field, it refracts the light like at the images. You're losing the debate, bro.
Icy Spin says, JK, Astro Kate, love you. Eric Burns, there it is. There's the one about periodic tables, just hydrogen, helium, and metal. Mr. E-Man, he said, your laser to stun. I just want to make sure I get everything that's addressed to you. Sent you a DM on this topic. I got it. I'll queue it up. Mr. E-Man says, my cat is wearing the cone of shame after his surgery.
Oh, I'm so sorry.
What surgery was this? So Gazelle recently got fixed and they didn't even give her a cone of shame. They're like, yeah, we spray some stuff on it so that they don't want to lick it. So, Scotty Orange says Rossi, the speed of dorkness on the other hand. Okay.
That's infinite.
Monkey Cat Pat Pat says, can I come on and prove I'm not Astrocat? The problem is if he did come on, you would all of a sudden have to leave.
Yeah, something would pop up.
That's how it works. All right, and Icy Spin says, Astro Kate knows I'm teasing her. Max says Kate is his hero.
Nice.
There you go. But also, Max was trying to comic shop guy the pronunciation of Beetlejuice. Like, well, actually, that's not the pronunciation. Max, no, it's Beetlejuice.
Yes.
All right, I got the clip. Oh my gosh, I got a clip of Dearth. Jeez. Hold on. Got to name it because it's
so the other thing too, I refuse to call the seventh planet anything other than Uranus for obvious reasons. There are just certain things you have to call.
I know.
Yes, there's certain astronomy you have to adhere to. Don't say Beetlejuice. Don't say Uranus 3 times.
It's
Uranus.
I love that it is not only is it such a goofy middle school name, but it's the only one that's the Greek instead of the Latin name.
Yes. Yeah.
It would have been Kylus.
It would have made sense.
But nope, they're like, no, man, bro. We've got to make English speaking middle schoolers chuckle.
They knew
for all of time.
Yes.
So All right. I got it here. Hold on. Dearth. He's so dumb. Where is it? Oh, wait. What? Oh, it's in the wrong folder. Hold on.
So I will save you. The Canadian Space Advocate says never talk about sending a probe to Uranus. That is true. You do not have to send a probe to Uranus to explore the gases of Uranus.
You can do it with
It can be manually.
spectroscopy. Oh my God. You can also, yeah, there's the okay, so Garrus. Is Garrus here? So I'm in a chat with Garrus and a few other people, and Garrus posts this Ewok prostate exam thing. Right? If you've probably seen it, a lot of you have probably seen it. And then nobody responds. And then Garrus posts it again later. And nobody responds. And Garrus is like, how come nobody's responding? You know what I did, Garrus? I DM'd everybody else in the chat and said, don't respond to Garrus about the Ewok thing. Pretend you never saw it no matter what he does. So there you go, Garrus. I don't know if he was here earlier. You could watch it later, Garrus. That was just for you, messing with you because we love you. Okay. Here's the question of the century from Dearth.
You know, the moon shows up at night, and sometimes it shows up during the day.
It's about 50% of the time at night and about 50% of the time during the day, Dave. Amazing.
Right?
Mm-hmm.
How come the sun never shows up at night?
Oh my God.
So it does show up at night.
Oh my gosh. How can he be that dumb?
It's a clip of me.
Yeah. Oh my gosh. I didn't expect that. How come the sun doesn't show up at night?
So I found out you actually can see the sun at night.
Oh my gosh.
So,
Oh my gosh. I'm
you're still
sorry
going.
I didn't warn you.
This is Icy Spin's
sorry I
clip
didn't
of me.
warn you.
He just keeps
so
going.
dumb. He's so dumb. Oh my gosh. How did you do that, Dave? How did you get so dumb? How did...
Okay, that was done. Sorry.
Yeah, so I recently saw an image of the Milky Way. There was a panorama from the top of a mountain, and you could see. And oh God, I wish I could find it. But Alex, there was. You could see the two arches. There was a panorama of the Milky Way, so you saw, the Milky Way sort of two arches, and then in the middle there was this like other arch, and like, what is that arch? Well, he was using a really long exposure that he stacked all the images together. And basically what you're seeing is that if you do this, if you take like a DSLR, put it in a very dark skies site and look out, do like a 360 panorama, you can see the sun light reflect off the dust in the
solar system. Oh.
Yes. I did not know that was the thing. It totally is a thing. So you can technically kind of see the sun at night. But yes, that's, believe it or not, I think Dearth might be a little stupid.
But it didn't, but it didn't come out at night. But also, and people saying you can see neutrinos, and of course you can.
Yeah.
And neutrinos, the neutrino detectors detect the direction that the neutrinos are coming in from as well, because they hit something and then they scatter in a certain direction. The particles that they make scatter, so they know the direction it comes from. So, and because neutrinos from the sun have a very specific energy magnitude, we know they're from the sun versus neutrinos that may be from elsewhere that would have a different magnitude.
And that's what I need for my lab. So I have that little, Tesla coil. I have the spectrometer. I need a neutrino detector. I need a GoFundMe. Fund my neutrino detector.
That might be a little hard. But now Jordy LaForge had one just built into us. He's just like, oh, look at the neutrinos going. I see the neutrinos going. Like, how did you see? I'm like, hold on a second. You didn't see the neutrinos going over there. How are you seeing them? You can't see them.
Subspace harmonics.
Everything, yeah. Answer everything in
Explain it.
subspace.
Yes.
Okay. Oh my gosh. Jack Fetter says, make sure to tell Mikey he can see certain galaxies and nebula through his binoculars with his bare eye holes, proving his pics are just noise.
Oh, he does know the Orion Nebula. He identifies it correctly. He's taken
Really?
pictures of it. It has that blue tint. He refuses to believe it's anything other than like an electrical storm or something like the electricity.
Because you can tell that something's electricity because of pictures of it. That's how it works.
Yes.
Because he's so dumb. I mean, he's the GOAT. Icy Spin says, I sent you a very on-topic, amazing video for the people. That's the one I just played. Thank you, Icy Spin. Unfornicated says, Mikey and Sam's neurons fire at the speed of dark. I think he misspelled that. At the speed of dork. Yep. Scotty Orange says, anybody have any astronomy-based pickup lines? No. I think he's meaning them for you. So you don't need to provide them. You just need to test them out and whether or not they work, I guess. That's what I'm guessing.
So the best pickup line, if you're interested in my attention, is I have access to a 10-meter telescope.
Lots of jokes could be made on that.
I didn't mean it like that.
I'll just leave it as an exercise left to the audience to make up jokes on that topic. All right, Scotty Orange, you've got a job. You've got a task. Rick Tibbet says it's big trouble if Betelgeuse gets near Uranus. Then it's all middle school today. Rossi says, proving it's middle school, says, Toon as Mikey posted a photo of Uranus. Oh my gosh. Do you think that his setup could get a smeary picture of Caiaphas? Kylus.
Maybe. So you can image Uranus. No jokes.
You can't not have it be a joke.
With a very modest setup. So like my telescope, it has an aperture of like I think it's 78 millimeters, my small refractor. And
what's the one behind you that we see?
Oh, that's a reflector.
That's the C star?
No.
What's the C star?
No, the C star's in a box.
Okay.
The one behind me is the Celestron Edge HD8, which is 200 millimeter aperture, 2000 millimeter focal length. The small one I'm talking about, I can bring it out some other time, but it's not much better than binoculars, but it does have a very good sensor that can pick up very dim light. And I've been able to image Uranus and very well, and it's a little funky. It's hard to make out details.
I'm gonna go stand off screen for a little bit here.
It's pretty dark. But it's gassy. I'll be honest. You can tell it's a gas, but that's about it. It looks, but
you don't need. It's dark and gassy.
You do not need really good gear to see that it's there. In fact, I've actually imaged Pluto with a small refractor.
Really?
It just shows up as a dot. Yeah.
Yeah.
The key is that the camera can expose for 5 minutes, and it has really good tracking. So there's multiple cameras making sure that the telescope is always pointing at the same part of the sky.
Okay.
On an equatorial mount, of course. So I can take these 5-minute exposures, and then sure enough, there's Pluto.
Wow.
So technically you could, if you were really if you really hated yourself, you could take a pair of binoculars, chop off the eyepiece, throw in a astronomy camera that's cooled, and put it on an equatorial mount, and you could probably get Uranus.
All right. All right, hold on.
Uranus for everyone.
Yeah.
So somebody says Patch Von Braun says, hey, I run a 12.5 meter telescope, but you already know that, Astrocade.
That's true. And you know what, Patch? I'm already down to go visit Patch Von Braun. Like, he's living my dream right now. He has access to a radio telescope observatory. So
that's pretty cool.
yes.
Mr. E-Man says I can get access to a 10-inch f5 Newtonian telescope. That's nope, meter, not inch.
Oh, 5 meter?
No, he says inch.
Inch.
10-inch. It's probably 5.
And they always exaggerate too. Like, they say it's 5 inches, but like,
yeah,
you know how it goes.
You bet. 10 inches. I see Spence's Astrocade is hilarious. Yes. Oh my gosh. We are all just, we're all just middle schoolers. Jack Vetter says you could probably pick up a neutrino detector at the Army Navy surplus store where Whitsitt got his gyro compass. Oh my gosh. Poor guy. Icy Spins is 10-inch on tender. Okay. Now you've said you don't know a lot of the flatties. Do you know? I know the answer. This is just for the audience's benefit here. Do you know of Aloha from Florida?
I don't, but I do like the juxtaposition of the Hawaiian phrase and Florida.
Yep.
Because when I think of Florida, I'm always thinking that reminds me of a Pacific island.
Yep. Because that's definitely it. Okay. So here he is. Few people are. I mean, maybe only Mikey is the more goaty goat of anybody than this guy. All right, I'm going to see if I can share this to you here. All right, share. Now you see that, right?
Oh, that guy has like crazy eyes.
Yep. Well, yeah, he has something underneath his right eye, like always there. It looks like a blood blister of some sort, but it's always there. Don't know why, but it never goes away.
Well, I'm not going to poke fun of his appearance, but his eyes definitely like, whoa.
Yeah. All right. So, that's not it. Hold on. Copy.
Yeah, it might be a birthmark. I mean, let's not.
All right, there we go.
Or you know what? They get those prison tattoos. That's what it must be.
Yep. Yes. That's what it's a prison tattoo. All right. So here he is. This is stupid and intelligent. No, wait, smart and intelligent versus stupid and ignorant. Okay. This is he's gonna learn us about the difference here. All right. Get ready. Oh, no audio. Did you hear anything when that was playing?
I hear nothing.
Nothing at all. Okay. What? I gotta fix my to Zoom. Why? I didn't even hear it either. So I don't know what. I know why. Okay. Where did it go?
I like how both of us are computer experts. We still cannot figure out how to get our audio correct.
I know. Well, audio routing is really a pain in the butt when you're doing live streaming. Mm-hmm. So, all right. There it is. 1 electron, 2 electron. Now I got to go to, that's to Zoom. Now I got to do the same to OBS. There. So I have 2 electrons running. It's a Python web browser.
So my alter ego says this guy looks like a lawsuit waiting to happen. It totally does. But
Yep. Okay. Electron. Okay. That. Add back in 1. Add back in 2. Now, let's see if we hear it. When I hit play. Still no audio. You don't hear anything, do you?
nope.
What in the world? Okay, I'm going to have to change.
We are audioless.
I'm going to have to change how I'm doing this.
Yeah, the flat Earth pendant.
Oh, yeah.
I wonder if it's one of those like flat Earth pendants.
It
like,
is.
or the 5G pendants. Like,
Oh, he
it's
is.
still.
He is so much into the Kool-Aid. He is 100% Kool-Aid.
I still have this for a rainy day, by the way, which is the negative ion stickers you put on your phone to block 5G.
Of course. All right. We're going with plan B, which is sharing a browser window instead of the app that I wrote that's supposed to be awesome, but it's not being awesome today.
Did you write it or did AI write it?
I am the software architect of this thing here, and I just have junior programmers that do the work for me.
Yeah.
In this instance,
Lame.
the junior programmer is called Composer 2.0, which is also called Kimi K 2.5 with extra RL.
That's that way. So that's the beauty of AI. It's when the program fails, it's not your fault. The AI coded badly.
Yep. All right. Fix that. Get rid of this. Add in browser. Window capture. Browser 4. Because never have enough browsers. All right. Almost there. Almost there.
We need some
One more.
elevator music.
Okay, people can see him now. And now I can share it to you. And hopefully the audio works after all this work. So here we go. Oh my gosh. There's no audio on it. That's why.
There's no audio. Yes.
I downloaded this from TikTok today, and there's no audio on it. I watched it on TikTok, and there was audio. Why did it not download with audio? What is going on? All right, hold on. I downloaded 3. Well, this one has audio. And this one has audio. Okay, well. All right. All right, all right, you're seeing it. It's sharing to you.
Mm-hmm.
All right, let me. All right. Almost there. There we go.
I really need to get a soundboard.
Okay.
Like,
Got it. All right. So I don't know why that one audio didn't work, but so this one here, the audio does not work. Oh my goodness. The only one that the audio works is this middle one. Okay. Well, we'll watch this one. Okay. It doesn't matter. Everything out of this guy's face hole is dumb. So here we go.
Good evening, aloha from Florida. So here is the famous gravitron that spins around, and while you're on the inside, it pushes you up the wall because of the centrifugal forces. And Neil deGrasse Tyson says if you weigh yourself at the equator, you'll weigh less because of the centrifugal forces of the Earth. What Neil forgot to tell you, if you're in a weight loss competition, make sure you weigh yourself at the equator while the full moon is overhead, because the Globers say that the full moon pulls on all the water on the earth, and your body is 71% water. So if you really want to weigh less, make sure you weigh yourself at the equator during a full moon when the full moon is directly overhead, and you'll be like 50 pounds less weight.
50 pounds less weight.
Those are words that he said.
50 pounds less weight.
All right. Well,
Yep. Yeah.
I do like his taste in theme park attractions because the Gravitron is so fun. And it's been around forever.
Yes.
So, and so I remember that was like before I was brave enough to go on roller coasters, that was like my first ride.
Oh.
I'm surprised they still have them. But when you were little, they let you like go upside down when it like because you go on the wall, it spins really fast, and then like you can go upside down and like hang out upside down. It's so fun. Anyway, so he has good taste in rides, not good taste in science or hats or pendants.
50 pounds less. Oh my gosh. How can you be that dumb?
Isn't that insane?
It is. It is.
He's not totally
because you're wrong about the magnitude. Oh my gosh.
But he's right about it being insane.
Or maybe you weigh the same everywhere across the surface of our flat and stationary Earth. Whether
But no, this has been empirically tested. Right? Like he just screw all of actual evidence and he throws it all away and substitutes with just a declaration.
Yeah, he rejects all of humanity's science and substitutes his own.
That's it. That's how it works.
Yep.
you weigh yourself in Canada or you weigh yourself in the Bahamas, you weigh the same everywhere because the Earth is flat and stationary. It doesn't move. There's no centrifugal forces. Go check out the mechanical realm by...
He said there's no centrifugal forces. In order to buy gold, like they will not let you buy gold at the equator and then sell it.
No,
you know,
they do, but they use a balance scale instead of a spring scale.
Right, but you have to use a balance scale.
Yeah,
like it. This is so dumb and obviously false.
All right, look, here's what you look up there. Aloha from Keith Cameron something is his name. The International Galaxy Standardization Network, IGSN 71. It started in 1971. Look that up. There are thousands and thousands of measurements of the variation of gravity all over the surface of the Earth. And it is minimized at the equator and maximized at the poles. You don't get to argue this. This is just measurements that have been done.
Or, someone on YouTube said that's not true.
Yeah, therefore, that's it. That's
all the proof I need. That's
all he needs. Cola guts. I'm not going to read that one. Jack Better says, Toon, the other day, Sam said telescopes aren't as good as binoculars. Oh, hold on. Telescopes aren't good as binoculars because they use mirrors. Please break it to him gently on Friday. Oh my gosh, yes, binoculars have mirrors. I mean, not all of them, but if they have the little jog in it, like Mikey's do, that's two mirrors. Oh my gosh. Oh yeah, I heard about this one. Our Icy Spin says Arwen did a no audio stream recently. His best show. He was just silent the whole time. Not all of it. I think he realized late. We are all Golgafrinchian says it would take Earth rotating at 5,075 seconds per rotation to balance the effects of gravity. Yeah, this is the kind of stuff that we can just do a little bit of math to, and all you need is maybe high school math. And here we have Monkey Cat Pat has joined us. And just a second here.
What's going on?
Here we go. Here's Monkey Cat Pat. How you doing?
Hello. I am not Astro Kate. Please.
But
For some reason, Astrocade seems to have been gone missing.
Oh, no.
Where did Astrocade go? I don't know.
Where's she? She's okay. No, because now Mikey's gonna see this and be like, they are the same person. Astrogate, please come back. We couldn't fix this.
Where's Astrocade? I don't know where she is. Where'd she go?
Oh my god, please come back, Astro. Please, we need to fix this. Because I'm sick of Mikey saying that I'm you.
Oh my gosh. We got technical difficulties. Please stand by. Oh my gosh. Oh, RG Silver says no sound. I think there's sound. Say something, Monkey Cat, Pat.
Banana Republic.
There you go. Banana Republic. And now say something, Astrocate. Oh no! They're both on screen at the same time.
Banana Republic. But yes, so Mikey cannot distinguish normal people apart.
No. He cannot.
And that's the thing. Like, that's why he's so upset, because he thinks the person who is meanest to him is also everyone else who's nice to him.
Monkey Cat, Pat is not the meanest to Mikey.
No.
I'm the nicest. I've been so nice to Mikey.
Yes, both of us have been very nice to Mikey.
Yes.
But there are some people, I will say, who aren't as nice as me and Monkey Cat Pat. And I just think Mikey thinks everyone he meets is the same person.
It must be.
Yeah.
Hey, I'm sure Mikey's watching this because I can't talk to him anymore. He refuses to respond to any of my messages. Hey, Mikey, you're a good guy. I respect you. But let's have a chat sometime, please.
There you go, Mikey.
Yeah.
A heartfelt invitation.
Mikey, I still have more pictures of Sirius that I took with my binoculars and my cell phone.
That's so cool. And your binoculars that have no mirrors in them, right?
They have a few mirrors.
Oh, no, they don't. Because Sam said they don't.
Oh, right. Sorry. There's no mirrors or prisms or anything in binoculars. They are more natural than telescopes. That's why you got to use them. They're more natural.
It's crazy. I mean, binoculars are two telescopes. That's what they are.
No, they're not that. So the difference between a telescope
Leave it.
and a
Leave
binocular,
it. Okay, go ahead. Go ahead.
like a telescope is the most basic thing. It's just an objective lens and an eyepiece. And a binoculars have an objective lens, a prism, another prism, and then an eyepiece.
What are the prisms for?
If you ever look through a telescope, and this is really annoying. So you will see, like, if you're tracking the night sky manually, you look through a normal telescope, you will see a star go up and out of frame. So the normal thing you would do is move the telescope up, but everything in the telescope is actually upside down. So when it goes out of frame, you actually have to move it down to move it back into frame. And so what the prisms do is it bends the light 90 degrees, then another 90 degrees, so it's right side up again. So very natural.
I got it. Okay.
Very natural.
It's less natural.
No, it's more. You cannot get more natural than binoculars.
Oh my gosh. All right. Tim Davis says binoculars better than telescopes because both eyes. But Mikey doesn't use both sides when he's doing his. You know what? Maybe Mikey
No,
needs.
he uses one.
Maybe that's what Mikey needs to do to truly see the firmament. He needs to get 2 cell phones and put one cell phone on each of the eyepieces and then digitally manipulate the photos together into one, because that's how you see things naturally, is by digitally manipulating things.
Yeah, basically, I figure out how to do the depth perception, though. That might be a trouble.
There you go. Then you can measure how far away it is.
I want to do that for realsies, though. So one of the problems with telescopes is you might have to image all night. Imagine if you had 2 exact telescopes side by side.
Oh, yes.
You could double the amount of data you get in one night for just double the cost.
Fucking get like 5 of them. You could quadruple.
That's what they're
Quintuple.
That's what they did in Peru, right? Where's the Vera Rubin? Is that Peru? Argentina?
Chile? Vera Rubin?
Chile. One of them. They're all the same. Uruguay. Right, Max? But there's all right, Icy Spin says Chile.
Yeah, Chile.
So there's like 2 or 3, not the Vera Rubin one, which is the new one that's super big. There's like 2 or 3 of the smaller ones. And they sync them together to basically do what you just said.
Yeah, so
you put them all together and you get your depth perception through it.
you can
do
get
it correctly.
well. The stars are so far away. You usually get depth perception by taking a shot in the winter, and then again in the summer, and then you can use that to sort of do a little bit of depth perception for nearby stars. But one of the things you can do in radio astronomy is you can set up entire arrays of telescopes all over the planet, and then it sort of like acts like one giant antenna. We can't quite do that yet with optics, but we're getting really close.
Very long baseline interferometry.
Yes, very long baseline. Thank you. That's the actual correct term. But yes, we're getting very close. So one day we will be able to have like an Earth-sized telescope. That'll be fun.
Can't wait. Froggo129 says I use trinoculars, and that's just because he recently watched the Schwarzenegger Mars movie.
Oh, trinoculars for mutants. I like it.
That's the one. So Slithery says that's what Reds did when measuring the distance and speed of the ISS. Yeah, so Reds and Astronomy Live were 1.5 kilometers apart, and they both got video of the ISS transiting the moon, and then they used the position of the stars behind the moon to do some parallax measurements to measure how far away the moon was. No, to measure how far away the ISS was. Mm-hmm. Yes, Total Recall, Slithery. I don't know why.
I was about to interrupt and I didn't want to, but
I don't know why I didn't. I remembered very long baseline interferometry, but did not remember Total Recall. There you
I just
go.
remember to recall where Arnold's eyes go, ah! He was like on the surface of Mars. He just goes, ah!
Yep.
His eyes are exploding. So great.
Can you imagine if you actually were in the vicinity of something that released enough oxygen, enough atmosphere to actually re-atmosphere all of Mars, and you were like right next to it? You wouldn't be like, oh, wind blowing by you. Like, you'd get ripped apart.
Yeah, you just be you just pop.
Yeah, it'd blow you pretty far. All right. Rossi says, let's see, looks like Astrocate to me on the bottom there. Yep. There we go. Icy Spin says, this deserves a 10. I'm so dead, dude. Well played, McTroll. It wasn't me. It was Kate. It was Kate. Credit where it's due. She, when Monkey came on, she went off. It was all her. Oh, so funny. Oh, well, unfortunately, I could not get the video of the one that I wanted. Is so incredibly dumb. But I'll save it. I'll get the copy with the audio,
and I'll get that one for a future time. And Kate, you can watch it, and you can be amazed.
I somehow doubt that.
You can be amazed at how dumb he is. Every time I hear that guy talk, I can't believe how stupid he is. So just before we went to Antarctica, he did a video claiming that we would not see what we did see, the 24-hour sun. He made that very clear that we would not see it. You know where that video is now?
Deleted?
Gone.
Yeah,
Gone. He deleted that video. I saw it. I did not download it at the time. Maybe there's a copy out there. If somebody can find a copy of him talking about it shortly before we went to Antarctica. So it would have been maybe October, November, maybe even early December of 2024, where he said that, where he made a prediction of what we would see, and he was completely wrong. I was looking for it today. I was sitting there on his TikTok, and I'm like, previous day, not there.
Yeah.
Yep.
It's a religion. They're not out to find the truth. It's a cult.
Yeah, it's a cult. It's basically what it comes down to is I love my cult stuff. I enjoy dealing with cults. It's Flat Earth is a cult. That's why I am into this community. Because Flat Earthers are members of a cult when it comes down to it.
It's a cult, and it's not even a cool cult. They don't even have like robes.
No. It's not even a cool one. A cool one.
People don't even try to do speed runs into their buildings.
Yes.
Right? They don't have offshoots of their cults where they have lots of wives. None of that fancy stuff.
It is the lamest cult.
It's the most boring cult. Like, I can look into Scientology and like stuff like that. It's more entertaining.
It's got Xenu.
Flat Earth, you're like, okay.
Scientology has Xenu. Mormons have Kolob. Like,
hey, at least Scientology believes the Earth is a globe, though, right?
They do, yeah.
And that wasn't it like ancient people, like their souls were like put in volcanoes and then like exploded.
Yeah, not people, bad entities, whatever that I forgot they were called.
Bad people.
Yeah.
No, but it's like bad. They're like Thetans or something. Like anyway, they're in the volcanoes. It's all very scientific
and it
very technical.
Backfired. It backfired on them because then their souls were then released from their bodies and they could haunt people.
Yes, like Beetlejuice is now haunting my place.
Basically,
Beetlejuice. We're all dead.
Yes. Yeah.
So, I like Beetlejuice. I like that movie.
It's a great film.
One of the best. And it was which Star Trek was it where she was Spock's mom?
I couldn't tell you, man.
Somebody will know.
Chat, what do you?
Come on, chat, help us out.
Was it the 2006 one?
That's about the right time frame. Yeah.
The reboot Star Trek.
Yeah, and I didn't like the new parallel universe. I don't like the reboots. Come on, people. Famous Potato says Kolob is a poetic name for God's home. Well, it's like it's a planet or a star or something, and they sing songs about it. They're goofy. I sometimes watch Alyssa Grindwall. Is that her name? She's an ex-Mormon who basically tells all. And she recently did it. She's too nice. She did a video on the Scientology speedruns. And she's like, I don't know if I like that. I'm like, I love that. That's amazing. She's like, they're just not being nice. I'm like, you're just too nice. You're still too Mormon.
Yeah, no. Mormons are fun to talk to. I have nothing against
them. They're the greatest people around. Seriously. Yeah. Right. It's goofy, but hey, they're amazing people.
Yeah. If I think anyone who's maybe more tolerant of religions, it has to be the Mormons, because if you look at the religion, it is the beliefs are batshit crazy.
They're bonkers, right?
Yes.
It's
But
so
you
much
talk to
fun.
them. You talk to them, and they are awesome people.
Yeah.
Like,
Yeah.
and I want to be their friends, and I want to support them. Whatever they're doing to be like this awesome, I want to support them.
Well, I'm a big fan of like UFOs and like alien stuff like that. And like Mormons, if I'm mistaken here, their god is an alien.
That's-
Mormon? No.
Well, you
Not
know it's
Mormons.
true. It's
Not
true.
Mormon.
No, it is true.
Scientology.
The Mormons. No, Mormons
Yeah,
too.
no, it's an alien.
Yeah, so they thought like it gets really deep. You have to be like really into the Mormon church to learn this, but apparently like Jesus was an alien actually,
Yeah.
and
Yeah.
like come and like heaven's another planet or something. I forget the details, but it gets really strange and
It gets
awesome.
deep.
Yes.
It's wild. Like I
Yeah.
love talking to Mormons.
Okay.
It gets really fucking weird.
Yeah. Like I said, I have no. If you are a Mormon, God bless you. Literally, like have the time of your life. Be awesome.
Yeah,
Don't mind the
same,
fact that I think you're.
blessings.
Yeah. Don't mind the fact that I think that it's crazy because I think you are an awesome person. And
So you know what? One of my favorite things is they do baptisms for the dead, and some people get offended by that. Like, and I'm like, you know what? They're spending their time and their money and their effort to do things for somebody else.
yeah,
How can you complain about that?
I don't know.
So I think that's an amazing thing that they do. So
I don't know.
whether or not you
No.
yeah. So I think he's saying it's not a. Oh, so we've got Scotty Orange as an ex-Mormon. I can confirm they believe that sort of thing. But Famous Potatoes, I think, is disagreeing. I'm not sure.
Oh, and you know what? That's fine. I know there's a lot of Mormons who are sort of like Mormon, like, and they don't get into their nonsense. Yeah.
Yeah.
It's
Like,
yeah, it's
It-
hit or
it's-
miss.
it's like Christians. Like, you know, you'll meet some Christians who are like, oh, Earth is 6,000 years old and all this stuff. Vast majority of Christians are just normal, rational people. Same with Mormons. I mean, we're talking about the very fringe Mormons here, by the way, when we're talking about like the alien Jesus and stuff.
The fun part of Mormonism.
Yes.
Yeah.
Yes.
All right. So Simeon says, I find that gross. I think the baptism for the dead is what he's talking about. Whether or not you agree with it, here, this is what I appreciate, that they are putting in the effort, sacrificing their money, their time, their treasure for somebody else. Like, how much more can you ask for than that? I mean, that's just, I don't know. Whether or not you agree with it. So
We have Riley in the chat, who's a Mormon.
Yeah.
Thank you for joining us and gracing us with your presence. Like I said,
He was meowing. at the
every Mormon I've
door.
met has been
I didn't,
fantastic.
I didn't think you realized there's puppies in here.
Cat.
I've got, oh my goodness. Yeah, but there's dogs on the floor. So he's like, no, get away. Hold on. Okay, calm down. You can't see the dog. I don't know how much longer I'm going to have this guy because my son's back. We just need to get the back from Scotland. So we just need to get the cats back to him.
Yeah.
Go.
Dude, I don't recognize that cat. That's a different cat.
Yeah, this is Cotton, my son's cat, who we picked up from Montevideo, Minnesota, for him. All right, here you go.
Oh, he's a pretty boy.
He's the one, when he gets super happy, he'll come and he'll do he'll knead on you, but we call it making biscuits.
Making biscuits.
Making biscuits. Decal Badger says, I know it's not really true, but I kind of automatically assume anybody from Utah is a Mormon.
I do too. Like every time, like I meet people, like, I'm from Utah, so you're a Mormon, right?
It's
They're like, no,
it's just a large percentage.
it is.
Yeah.
Utah is such a beautiful place too. The
It
mountains and the salt flats. I highly recommend people go. And the people there are super nice. Just if you're looking for a place to go, check out Utah.
Yeah, Utah's beautiful. Like if you really want to like see the United States, especially if you're not from America,
Yeah.
you want to come to America and see America, like Utah. Like it's beautiful.
Famous Potato says, now I'm soured. Okay. There it is. This says it gives ancestors' spirits a choice to accept Jesus. And I know what that is. I've tried to become familiar with what that is. And so I think that's, I don't know. What was I going to say about, I don't know. I've never been to Utah. Want to go there someday. Riley Levson says, we're full, don't come.
Yeah.
Exactly. It's amazing that Kyle Adams is a Mormon and a flatty, because it doesn't really match.
None of it makes sense.
No.
With Kyle Adams, no. Like, if he's really was a Mormon, he's not a flat earther.
You can't. What about Kolob? Come on.
I miss Kyle Adams. Is he still around?
He is, but he's very echo chambery. He doesn't like to have anybody challenge him. So, yeah, and you are victorious. Victorious says Kyle is just very dim. He is super, super dim, and he's taught his kids to be flatties. So that's unfortunate.
Just sad.
Yeah,
that makes me sad.
So on the few occasions I've talked to flirfs, I generally don't care that they're flirfs, but I will go after them if they try to indoctrinate children, and a lot of them really do.
Yeah,
that's the thing. Like I have not gonna lie, I've talked to my therapist about flat earth stuff, and he's like, well, as long as they don't bring up the kids. I'm like, oh, you motherfucker, wait, they do.
Yeah. Now, somebody the other day mentioned that Quantum Eraser's daughter is some sort of academic. I don't remember what it was. Has some sort of an academic position or award or prize or a competition or something like that. I don't remember exactly what it was. But I'm like, yeah, obviously she's not a flatty. If that's the case, because you can't be smart and a flatty at the same time.
There are smart people with weird beliefs.
Yeah, there are smart people with beliefs, but at the same time, you gotta look into it.
But there aren't smart people that are flat earthers.
Oh, there's.
I've never seen one.
I know. I can name one exception.
Evidence of absence is not whatever that quote is.
Something like that.
Yeah. Absence of evidence is not evidence of absence.
Well, no, Tuna, I'd like to see what is your one excuse for a flat earther?
The one smart flat earther is a guy that called himself Mind of God.
God damn it.
Shiraj Patel. And he is to best of my knowledge, he has a master's degree in electrical engineering and knew geometry very well. And his position was, and this is a problem, was that, yep, everything looks like a sphere, but that's just God making it look like a sphere. It's actually really flat.
Oh, good Lord.
Which is a problem, because what he's basically saying is that God is deceiving everybody. Anyway, he's disappeared. I've looked for him. He made some. He said he said some things that would be self-terminating if some things happened or didn't happen, and those things I think didn't happen, and so people have looked for him and can't find him. So I don't know. I have no idea, no knowledge, no nothing of anything either way. So I've tried, and other people have tried as well to get in touch with him. So
if you want to hear a good story about a crazy person who is also brilliant, I recommend everyone check out Terry A. Davis and Temple OS. So this guy, I kid you not, total schizophrenic, total crazy, created a brilliant operating system, and it's called Temple-esque because he thought he was building it as like the third temple to God or something.
Oh
and
no.
he's absolutely brilliant. Unfortunately, he did pass away a few years ago, but it is a fascinating story. He made his own programming language called Holy C, and like
which is a Catholic term spelled differently, pronounced the same. I don't know what it is in Catholic. I'm not super Catholic-y. So
yeah, he made his like own flight simulator in the operating system.
Oh no.
By himself. No, it's great. It's a great flight simulator.
I'm sure it's great, but
there was something called like After Egypt, which you travel to like a burning bush. Like, and he thought he was building this operating system for God. It's amazing. It's just such an amazing story. But we don't have the time. And
yeah,
that's
whenever somebody brings it up, I'm off at the Wikipedia page already.
Yes.
Like, amazing. Okay, you know what though? It's getting late, and I got a earlier day tomorrow than I usually do. So a couple things. Modern Day Debate, 8 Central Time on Thursday with Soli, and I think that's going to happen. I don't think it's going to get delayed again. Number one. Number two, we're still not yet solid. I wish we were, but on the Sam, it started with myself and Sam, and then Sam's like, what about Mikey? And then what about Creaky? I'm like, sure. And it was going to be all 4 of us. And then it didn't work because my internet went out, and I'm like, let's do it this coming week. And Sam's like, yeah, but that's kind of late for Mikey. I'm like, well, fine. Then Mikey doesn't need to come. Right.
Yeah. You don't need Mikey.
I think he'll still come. Right. What's he doing on Friday morning? Nothing. So anyway.
Hey, if you get a chance to talk to Mikey, tell him I said hey.
Hey, Mikey, everybody says hey. Everybody loves you. You're the GOAT. Everybody says hey. How about that?
Yeah, there you go.
I am this close to converting to flat Earth because of Mikey.
Oh, there he just needs to show up.
Yep.
I need to see more pictures of Sirius.
That's it.
Yeah,
he needs to go out there.
I need more.
He needs to go out there and take more pictures.
without mirrors.
Without mirrors.
The mirrorless natural binoculars.
Binoculars, yeah.
Oh, amazing. All right. Good old Mikey. You know what? You made a song.
Who?
Astrocate.
Oh, I did. Is it Bad Flirps?
No. Oh, you did that one too?
Yeah, I did Bad Flirps. That's Mikey. Oh, that'd be perfect.
I don't have it.
I don't monetize my channel. You can.
I know. I have a Mikey song.
You have a Mikey song?
I do.
No, do Bad Flirps.
All right, hold on. I'll find it, Caitlin. All right.
And by the way, my channel was not hacked. I used to have a Sora account. And then over the weekend, I was like, oh, Sora shut down. I got access to all my old videos. I'll throw my favorites up on YouTube. And people are like, why are these AI generated videos showing up on your channel? I was like, oh.
Yeah. My YouTube is just my AI songs that I made.
Okay, so Bad Flirps is 1 minute 23 seconds?
Yep.
Okay, hold on.
I'll throw a link in chat.
I'm all right. Downloading it now. And I'll drop it in my my folder here. Hold on. Let me get it here. There. OB. Video. Songs. Oh, is it a Mikey song?
It's mostly Mikey. It also goes over other Bad Flirps, like a certain Witsit.
Yeah, if anybody's interested, I have a YouTube. It's terrible, but it's just all my AI songs, and that covers a lot of flat earthers.
All right. Well, I got yours, Caitlin. Right there. Bad flirts. Okay, everybody. That's what we're going to go out on. Thank you very much, Caitlin, for your amazing training. Monkey Cat Pat Bat. Thank you for coming on to prove that you are not Caitlin.
You're not the same.
Although obviously you are
not the same.
You are just AI, and Mikey will never believe it. Everybody else, we'll see you on Thursday. See you then.
Subscribe to MCToon. See you guys.
Due to the graphic nature of this program, viewer discretion is advised.
Simpson, you're not making this easy on yourself.
What are you doing, buddy? Hey, I got this on YouTube, pal. You look like a clown. No shit, I am a clown.
I hope the Illuminati think they're gonna get away with framing me.
Who's going to be under arrest now? So we have 4.
I'm gonna come after you too.
Seems like you don't trust me. That's what all cops do.
I'm going to clubs. Maybe I might take a shit later. Maybe a piss. Go to McDonald's.
Am I being detained? Yes. Dude. Wow. On your back. You're under arrest. I'm under arrest. You're not on a spinning ball.
That's it. You have no to yourself. If you're not going to comply,
you're going to jail, buddy. You're going to jail, buddy.
What? Could I get your name and badge number?
Blurfs is filmed on location with the men and women of the Globe Patrol, all suspected guilty of not understanding basic science.